today we will discuss Turing machine as a computer of integer function. This is a computing integer functions. In this class, we will discuss about the how our normal arithmetic operation will be done by the or any computing done by the using Turing machines. So, like you can say addition of two number, some addition of a constant with a variables. If this mathematical function is there, how to design by the Turing machine. So, here we already know that our tuples of Turing machines, these are the tuples, 7 tuples. So, Q, this is input alphabet, sigma, then tau is the tape input alphabet, del is the transition function, Q0 is the initial state, and B is the blank, and F is the final state. So, already we know that in previous classes already we know what are the tuples of the Turing machines. So, we will go to how our computing the integer functions. We will discuss about that only in this lecture. So, now computing integer of integer functions. So, let us say one function is given. Oh, so, this is a domain, you domain and this is the result region. So, suppose one function is given like that, you can see this is a domain. Suppose fx is x plus 2, x plus 2. This means here is the some x value will take, you can say suppose x is 2, then here result will be like that, this is 4, this is the result region. So, this is the function, here we are taking a function, this function will give some value. So, like that if how to design using Turing machine, how to design using Turing machine. So, this is little bit complicated how to design whatever we have some addition operation like that you can do a plus b, a minus b, and suppose you have to find a to the power n, like that many functions you can be computing, whatever computing function that can be designed by the Turing machines. So, already we have some x value and we will be put that x value and fx will be give some different output. So, basic concept is that we have input tape and you have to take some input some argument or some variable like x, then after that you have to move in the Turing machine whatever you have to design, then you have to check your output either it is correct or not. So, now we have to see how will we go to that. So, suppose this is a decimal number, here we have one binary input, here we have binary input, here we have binary input. So, binary input means we have input alphabet is 0 1 0 1. So, unary input alphabet is, so here only 1. So, this is the unary input alphabets. So, while we have will be doing some computing function, you can as per your requirement you can take the binary unit input alphabet, or you can take that unary input alphabet. Means this, you see this 5 is the decimal value. Suppose we will take here binary, this is 101, and if we will take unary means this 5 is, this is 5 1, not it is just, it is a count 5 1, this is a count how many how many 1 are there, this is 5. So, means suppose here we have to take, suppose fx is x plus 2. So, x is 5, suppose x is 5, then this is 5 plus 2 is 7. So, in this case what you have to do, your input tape will be 5 1, input tape will be 5 1, then after the processing your output tape will be, when will be reach in final state, then your tape will be 7 1 will be there. So, like that you have to do in the Turing machine. So, here we have taken decimal number 5. So, as per your requirement you can take binary, sometime binary input alphabet and sometime you take unary input alphabet, like that we can do. So, here see here what we have written, you have a w and this is the q0 is the initial function, and see a function f is computable if there is a Turing machine M such that. So, this is the initial configuration, we have w, then after that final configuration is fw. So, this is the for all a w belongs to D, this is the domain. So, we have to design a Turing machine, and some Turing machine, that concept is there. We have some final state and initial state. We have to start from the initial state and read all the input alphabet on the tape. If you want, you can modify as per requirement. Then you have to reach in the final state. Then this is accepted by this way you have to design the Turing machine. So, it is saying that suppose same example we will take here, fx equal to x plus 2 we have taken. So, now what you have to initial configuration? Initial configuration will be suppose x is 5, then you have to take 1, this is 1, this is 1 and this is 1 and this is 1, and this side both side you can say this is blank, this one is blank, you have to take this is blank, or you can take as a B, this is a blank symbol. So, this is the initial configuration, What would be the final configuration? Final configuration will be, means you have to start from the q0. Suppose we will start from the q0, this is any diagram will be there, this is the you have to start from the initial state, and this is 1 1 1 1 and 1 and 1 and 1, this is the 3 4 7, this is the final configuration, So, this part is fw, this part is fw. So, now you have to take the w in the tape then after you have to run this function on the Turing machine, then after that you will get here final configuration, this is the 7 1 will be on the tape. If x is 5 and this will be fx will be 7, fx is 7. On this way you have to do it. First this is the initial configuration, then after add the 5, and sometime what you have to do, if you will consider as a binary input alphabet. So, for this suppose your tape will be like that, this is 5 means 101, then plus 2, then you will get here 7 means like 3 1 will be there in your tape. Suppose we will consider as a binary input. Here we take here unary input alphabet, and if we will take here binary, what will be there? First this one will be f, this is suppose this one is 1 0, suppose 1 0 1, this is the unary alphabet, this is fx, then after you have to get it 1 1 1, this is the 7. So, this 2 you can take as a something also 2, for 2 you can take a string here like 1 0 and give a space in between or something, you have to take a some mark symbol, means this is the x, and then after you have to take 2. So, we will go to one example how we will be doing addition of a 2 number. So, in this process you have to design your Turing machine. First one is the initial configuration, then after go to the final configuration and check it your fw is there in the tape or not. If not there, means you have done some wrong, you have your design is wrong. So, now we will go to one example fx equal to x plus y. So, this is the addition of two number and x, y are integer. What is Turing machine? So, this is the input string unary. Unary means you have taken here x 0 y and x y is 0. So, what is the meaning here? We have to take it x y 0, just we have to take this x, suppose here x is 2, x is 2, y is 3. So, here we have considered unary. This 0 is a just separation between x and y. 0 is a separate between x and y, and output will be x, y is 0. This will be output, and this 0 you make it in one side and add these two number and make it one side. In further, if you need, you can do it. Otherwise, you want to make it remove it, you can it. So, now you check it. So, this is x 0 y. So, x y 0. Now, this is 2, you can mark this is 1 and 1. So, this is 0 and this is 1 and this is 1 and this is 1. So, now this both side is blank, this is blank, you can take as a b as a blank, or you can write the symbol. So, in this case you have taken 2 3, your output will be like this. Output will be this is 1 1 1 and 1 and this is 1 and this is blank and this is blank, or you can take whatever 0 you have to make it there also. Another way you can do it. So, you can do, if you want to keep the 0, then you can do like this b 1 1 1 and 1 and 1 and this is 0 and this is b. So, you want to remove the 0, can it, otherwise you can to keep it in one side, you can it. So, in this way you can design your Turing machine. This is the input or this is the output. So, how to design, we will go to that only. We will go to addition of two number now we are doing. We will go to that. See here. So, what you have to do, read all 0, you have to input. Suppose here x is, let me do the example, suppose x is 2 and y is 3, y is 3. So, here this is 1, this is 1, we make a separation 0 and this is 1, this is 1 and this is 1. So, both side will be blank, both side will be blank. So, you have to make it 5, make it in your output tape at the end output tape will be 5. So, what you have to do, first in Q0, see how I draw the diagram. See, Q0 is the initial state of the Turing machine. For all x, you go move right, right, right. For all x, so x is 2. For all x, x is 2. Now, you have to make a loop here. This is 1, 1, 1, 2, right. For, so, before 0, if any number of 1 is there, just read that one and keep it on the tape and move right. Next, what you have to do next, you have to check it. If 0 is there, 0 is coming, again 0 will be replaced to 1 and move forward right. 0 will be replaced to 1, then move forward to right. So, now 0 replaced to 1 and right. So, now you are in Q1, clear? Now, Q1. So, Q1, what you have to do? Q1, we have to read all 1, then 1 right. So, all y, you read all 1s. So, y is 3 1 and read 3 1 and move right, right, move right, right. Then after you will get the blank. After reading all, you will get the blank, you will get the blank. So, this blank became blank will be, what you have to do, blank became, when blank will be there, just blank will be remain same and move left, clear. So, move left. So, now this is Q2, move left. Now, Q2, this is Q2, and Q2 you will find here 1. So, this is not loop. In Q2 you find only single one will be make it blank, single one make it blank, single one and make it blank and left. So, now this is Q3, Q3 what you have to do, for all 1, 1 and this is left. So, now when you will get here blank and this is blank, or you can say left, and this is Q4, this is accepted state, this is the accepted state. So, we will check it, is it doing the operation we have taken here 2 and this is the 3, 2, 3. So, we will start now, you check it from this diagram, we will check it. Suppose you have given 2 and 3, this is 1 and this is 1 and this is 0 and this is 1 and this is 1 and this is 1, x is 2, y is 3. So, because of unary we have taken unary input alphabet, means we have x is 2 1, y is 3 1. So, now you see start from the Q0, Q0.21. When Q0.21 you have to take the transition Q0 input is 1 and read keep it is 1, 1 to 1, then move right. So, next will be, you see next will be what will be there, this is Q0, this 1 and this is 1 and 0 and this is 1 and this is 1, this is 1. Now, I have not written the both side, you think this is a blank. So, now Q0, Q0.2, this second one of x. So, now see Q01 again in loop is there. So, what you have to do? Here Q0, now this is 1 and this is 1 and this is 0 and this is Q0, Q0. So, now check it Q0, if Q0, 0 is there, what you have to do? 0 is there, you have to change the transition from Q0 to Q1 and 0 replaced by the 1, 0 replaced by the 1. So, this is the 0 replaced by the 1. So, this is 1, this is 1 and this is 1 and here is the 3 1. So, this is the this is the 3, here is the, just a minute, 3 1. So, now both side will be blank. So, now you are in Q1. So, Q1 you move to right, this is Q1. Now, this is the Q1, you are in Q1. So, let this is a Q1. So, your initial, this one is the 1 1 and this is 1 and this is 1 and this is 1 and this is 1. So, you are in Q1, Q1 point to this one. So, Q1 point to this one. Now, you check if Q1 1 is there, what you have to do? For all 1 you move right and keep it is keep as it is 1. So, here what you have to do? 1, I am writing the direct step 1 1 1 and this is 1 1 1 1. So, now after this Q1 will be point to blank, Q1 point to blank, Q1 now head is black, because all 1 there is a loop in Q1. So, move right. Now, what will be what will be there when q1 blank is there, just you have to go move towards left. So what you have to do here, this is 1 and this is 1 and this is 1, then 1, then 1, then 1. So q2 will point to this, this is q2, q2 will be point to this one. Now check, q2 will be point to this one. So q2 1, check it, when q2 1, then what will be there, then 1 will be replaced to blank and that will be go to the q3, that will be go to the q3. So q3, now you check, this is 1, 1, 1, 1 and 1 and 1, this is 1. Now q3 point to this one, q3 point to, clear, this one is q3. Because q2 1 is there, you replace 1 as a blank, 1 as a blank and move to left. So now you check your tape, now q3 all 1, you have to move, you have to move your move to right, left. When q3 there is a loop, q3 1 1l, you move to left here, left. So on the left you will find the blank, find the blank. When you will find the blank, then you have to go to the q4. So at the end this will be 1 and 1, this is 1 and this is 1 and this is 1, and here is the q4 will be point to blank. So q4 is the accepted state. So you see, we have taken here x as a 2, y as a 3, and then this is 5 1. So your output is 5 1, output is 5 1. So we add the two number 2 and 3, we have take two separate number. So when we will add these two, then it is giving 5, then 5 is there in your output and both side will be blank. So in this way you can do multiplication, subtraction, like division, all the computing function you can be done by this Turing machines. So see this one, this is an example, this is an example given. So this is a question came in I think NET exam. So or some difficult, this is a very difficult questions. So you can see what function will be computed by this Turing machine, what function will be computed by this Turing machine. So we will take an example here. Suppose you will take here as a 2, we will take here as a 2x, we will take here as a x is 2 and we will check x is 2. So unary input alphabet, you take here 1 and 1, then after you check this is a blank. So then after check this symbol is a blank, this symbol I am writing, this symbol is a, yeah, this is a blank, this is a blank symbol, this is a blank symbol. So you can take as a B, I have written the B there, so no problem. So you can see here, for all 1 you have to make it dollar and move right. So q0 point here, q0 point here. So now it is q0 point to this one, then this is B. So you have to convert it to dollar and dollar. Then if blank is there, you back to the left. So now this is a blank B, now q0 point to blank, because it is written 1 to $r, means all 1 you have to replace it dollar and shift to right. So now q0 point to blank, if blank is there you move to left. So no, now you have to move to left. So this is blank and this is dollar and this is dollar and this is left. Left means now q1 point to dollar, q1 point to dollar. When q1 point to dollar, then what you have to do, this dollar will be replaced to 1, dollar will be replaced to 1, dollar will be replaced to 1. So, this is blank and this is 1 and this is dollar and this is 1, this is a dollar and this is a 1. So, now you see in dollar, this dollar will be replaced to 1 and move right, move right, move right. When this dollar will be replaced to 1, again move right. So, like that in Q2 again you are getting here blank, Q2 again you are getting, this is blank. So, this is blank, when you move right this is Q2, Q2 blank, you will get here another one, this is B dollar and this is 1 and this is 1 and go to left, left means like that Q2, then left means this is Q1. Then Q1 this is 1, Q1 1, you have to move left, left, left and like that your dollar is coming here. So, when you move left, so this dollar will be replaced to 1. So, what will be there? This is 1 and this is 1 and this is 1, this dollar will be again replaced by the 1, dollar will be replaced by the 1, then move to right. So, now this is Q2, 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 then after this 1 1 1 right, then here this is 1 1 1 and you can say this is 1, this is Q2 blank, Q2 blank is there, you have to make it 1 and Q1 will be point to, Q1 will be point to this one, Q1 point to this one. So, now Q1 all 1 you have to move left, left, left. So, move left, left, then after that you find the blank, you find the blank, this one is you have to find the blank in Q1 because no dollar is there, you find the blank. So, Q1 blank you have to go to the final state Q3, Q1 blank you have to go to the final state, this is blank. So, you can say Q3 and this is the accepted state. So, this is the accepted state. So, like that here option is this is C option is correct, Fx is equal to 2x, Fx equal to 2x. So, these are the reference. Thank you so much.